Yeah, so in this video, we're going to talk about the change of base formula for logarithms. And this change of base formula, as the name says, allows you to go from one log base to a different log base. And here's a statement of it. It says that log base a of x can be written as log base b of x divided by log base b of a. So basically, an easy way to remember it, as you see, it's easy to remember. It'd be like, if you're given this, you just do log new base of this divided by log new base of that. And that's it. Okay, and because nothing in math happens randomly, we can prove this. And in fact, I'll have a video proving this fact. And it's very short and sweet. It's about a minute long. So I'll try to link it below this, but look out for it. Anyway, yeah. And before I move forward and give you examples, from easy examples to harder examples, and one in between, before we move forward, the way you should prioritize in your log knowledge is that the change of base formula is kind of like luxury knowledge. And I say that because first and foremost is the definition of logs, right? In fact, proving the change of base formula requires that we employ the definition of logs. Most important is the definition. And then after that, probably product rule, and then probably power rule after the product rule, and then quotient rule, and then change of base formula. That's how you should prioritize. Okay, cool. All right, so now let's get on with the examples. And the examples, let's start with evaluating log base, let's say log base 3 of 81, right? Now, if we want to change this to a different log base, we could write log base 9 of 81, if you recall the formula I just had, divided by log base 9 of 3. I'll rewrite the formula, and that's again because we said that the formula said log base a of x is equal to log base c of x divided by log base c of a. Yeah? Okay, cool. And that's all I did here. Yeah? Okay, cool. But there's kind of some inconvenience here. Like, this is kind of hard to evaluate, right? Like, this is much easier. We can evaluate both this and this without a calculator, but I kind of don't want to deal with this. So what I'm going to do is like rewrite the problem. Well, actually, I'll return to this, but yeah, let's rewrite the problem and show you that like it's always easier to go from a bigger log base to a smaller log base than the other way around. Because like if we'd had like log base 9 of 81 instead, then we know that this is log base 3 of 81 divided by log base 3 of 9, right? Okay, cool. Now, this here is 2, right? So I have that. And this here better be 2, otherwise the change of base formula doesn't work. But this here is 4, right? And then this here is 2, so 4 divided by 2 is surely 2, so all is well. Yeah, cool. All right, now I did say that this is translating from this to this is harder, but it doesn't mean we can't do it. Like I said, we can. So let's do it. So first, we know that log base 3 of 81 is 4, right? Because 3 to the 4th power is 81, right? Okay, cool. And then here we go, log base 9 of 81 is 2. So log base 9 of 3 better be 1/2, because that's the only way we can make 4 if the numerator is 2. And in fact, we know that log base 9 of 3 is 1/2 is desired, because we'd say that this is equal to y, and then we go to the definition of logs and say like 9 to the y power is equal to 3, and as the square root of 9 is 3 and square root means an exponent of 1/2, we immediately conclude that y is equal to 1/2 as we wanted. So yeah, so you see how to kind of like deal with a basic example, and I'm gonna give you 2 harder examples now. Okay, cool. So first, let's say that you were doing like log base 2 of like 3, and then log base like 3 of like 4, and then let's say log base like 4 of like 8, right? So clearly none of the bases are the same, right? First of all, like we can evaluate this, but we can't evaluate this without a calculator. I said why in the video of the definition of logs, right? And likewise, we can't evaluate this because we won't know 2 to the what power is 3 in this case, and we won't know 3 to the what power is equal to 4 without a calculator. But this we can kind of exploit the fact that both 4 and 8 can be written as powers of 2 and be able to figure out what this is without a calculator. But the crucial thing here is the change of base formula. In fact, we'll be able to figure out what this number is, the product of this, this, and this, even though we can't figure out what these two are without a calculator. And we're able to figure out what this is without a calculator because we can use the help of the change of base formula. As you see, like this is the smallest base, so we're going to change all of the other bases to log base 2. So first, we want to keep log base 2 because we're changing the others into log base 2. So we write that. And then this here, by the change of base formula, is like log base 2 of 4 divided by log base 2 of 3, right? And then this here, by the change of base formula, and obviously we want to go to base 2 again, is log base 2 of 8 divided by log base 2 of 4. Okay, cool. We know that log base 2 of 4 is 2, but we don't even need to know it because we can cancel here and here. And then we can, if it's easier for you to see, I can write a denominator of 1, but we can cancel here and here as well. So this is equal to log base 2 of 8. But wait, that's equal to 3, right? So all we had to do is use the change of base formula, and now we know that this is equal to 3, even though, like I said, we didn't know what this is and what that is. Yeah? Cool. All right, so I'll give you like one other example, and this time involving a log equation. I have videos dedicated to log equations, but yeah, like I'll give you one example of how to use the change of base formula in the context of a log equation. And here's a log equation. So let's suppose we're looking at log base 2 of x plus 3 is equal to, and then it's log base 4 of, and then it's, let's say 2x plus 6. Yeah? Okay, cool. So, first, in order for us to like, do anything kind of nice here, like, to relate, to move forward in this equation, we need to get the log bases to be the same. Because here, first, if we're so lucky and we had an equation like this, right? Like, log base 2 of 2x plus 6, then we just say x plus 3 is equal to 2x plus 6 and go on with our life. Because obviously log base 2 is equal to log base 2. That's, one reason we could just set this equal to that. Another reason we can just set this equal to this is because logs are one-to-one functions. So this will equal that if the bases are the same, only if the arguments are the same, right? Yeah. So yeah. But like we're not so lucky, we have that 4, which is why we'd want the change of base formula, because if this is convenient, surely then we want to make this convenient by changing that 4 into a 2 somehow, right? And that somehow is using the change of base formula. Okay, so we go log base 2 of like x plus 3 equals, and then it's log base 2 of like 2x plus 6 divided by log base 2 of like 4. Right? Okay, and this would say log base 2 of x plus 3 is equal to log base 2 of 2x plus, I don't like that 2, it's like too small, 2x plus 6 divided by, and this is clearly 2, right? Okay, cool. And then next, I'm going to multiply by 2 on both sides of this equation to get rid of that denominator. And I could then write 2 log base 2 of x plus 3 is equal to log base 2 of 2x plus 6, right? Okay, cool. So here we are, all right? Okay. All right, next is, well, to make more progress, right? Like we don't like this too, and so we want to do something about it. And the power rule allows us to do something about it. Remember, the power rule said that log base a of x to the b power is equal to b times log base a of x, and of course this goes in both directions. So if this is true this way, then it's also true in the opposite direction, right? And we want to go in the opposite direction this time. So using this rule, we can write log base 2 of x plus 3 squared is equal to log base 2 of 2x plus 6, right? Okay, cool. So then now, we're at that step where this is the same as that and nothing is obstructing. So we could just say x plus 3 squared is equal to 2x plus 6. But this amounts to solving a quadratic. So let's do that over here. And so we know how to expand that. It's x squared plus 6x plus 9. And the right side is 2x plus 6. And we bring stuff to the left side to say equals 0, because we like quadratic set to equal 0. So that's x squared plus 4x plus 3 is equal to 0. And now we could use the factoring method for that. And that's x plus 3 times x plus 1 is equal to 0. So then we see that x will have to equal negative 3, or x will have to equal negative 1. Now we have to toss out one of these two answers because, well, we've solved it. So let's get rid of this and show you why you have to toss them out. But, well, one of them, because toss it out, I guess, not toss them out. Because if you plug this in into the equation you're trying to solve, it's supposed to be solving this equation, right? So if you plug in negative 3, then you get log base 2 of 0. We said in the what video was it? Oh yeah, in the definition of logs that you can have like log any base of 0, right? Like, so yeah, so this doesn't work, but this works, right? So in general, we said that logs do not take negative values, so you can't have log base 2 of like negative 4, right? But the fact that you got a negative answer doesn't automatically mean that that answer is bad. Like here, if you take negative 1 and plug it in here, you still have like positive 2 here, right? And likewise here, you better, otherwise it doesn't solve it, right? Yeah, okay, cool. So this is it, yeah. And lots more log videos to come, yeah, including a lot of interesting log questions that come from math contests, yeah? Cool, keep watching, take care.